Okay, so I think I sent the data set right in the last class. Were you able to check? Were you able to download it?
So you gave me the link, right?
Yeah,
Or
I think yeah, I think to download, I think you have to. I'm not sure. Let me try
give me the
now.
link. Yeah, okay, try it. I
Yeah,
have a GitHub account, so I can download. In fact, so can you send me a message right now?
yeah, sure. So, okay. Yeah, it's asking me to sign into Google to in order to log on to that.
Hmm.
Okay. Oh, yeah. Yes, I sent it on the chat.
Hmm.
That's the link to for that database, and
Okay, I'll download just now. I'll download right away.
I'm supposed to sign in using Gmail to download it.
Yeah, you can sign in using Gmail.
Okay, fine.
Yeah, for me it will take around 3 minutes to download.
Yeah, and then it's asking for profile also. It's saying profile URL and all. It's asking
Okay,
and full
so
name. So
what I will do, I am downloading it, and then what I will do is I'll create a link in Gmail, G Drive, and I'll pass it on to you. You can download from there. In that case, if there is a problem,
okay,
but
fine,
if you
fine.
can, yeah.
Sir, hello.
Yeah, then, yeah.
Oh yeah, okay. No, I just I thought I thought that it was muted. That's all. No, okay, so you're just downloading now. Then afterwards, I'll send because I think there's some. It's just saying I have to do all this stuff to download and all. So I think I'll once you can open it in a drive, maybe I'll download it.
Yeah, so for me it's in the 30 seconds, then I will upload it to my drive, and then I'll
Okay,
share the link with you.
fine, sir.
2 GB, right?
Yeah, it's just two GB only. It says.
Okay, so I'll just upload it right away. 'It's going to take 4 minutes to upload to G Drive, and then you are going to actually do you are going to
Okay,
download, right?
okay.
So by the time it happens, so what we will do, we will go ahead with something. Okay, after 4 minutes, we will go there, and then I'll give you the share the link. Then you can download it. Okay.
Okay, fine.
So I'll just take you through the other things like on the slides itself yesterday about where were we left off. Yeah, Adit, can you see this?
So are you sharing something?
Yeah, I'm sharing.
Okay, I'm not able to see it.
Might might come slowly. Okay, okay. Fine. Let it actually do. Right now we are just 2 minutes for uploading. Then yeah, we can go that way also. You're not able to see. Okay. Now you can see, I believe.
Uh, yeah, I can see now. So types of machine learning algorithms.
Mhm. So different types of machine learning algorithm. We have supervised learning,
Mm-hmm.
unsupervised learning, and reinforcement learning.
Fine. Okay.
So till now, whatever you have the data set, that is supervised learning because it is labeled.
Fine.
If you don't have a label data labels, and then if you try to learn from there, that is called unsupervised learning.
Okay.
If you want to achieve artificial general intelligence, then this is the only way, unsupervised learning. And reinforcement learning is also similar what child does, right? It falls, it tries, falls. It gets a thing. Okay, what the balance is all about, and then it slowly gets it.
Wait,
That
so for machine learning, sir, the supervised learning will have labels, and then unsupervised learning will be without labels. Then
yes, yes.
okay. And so you're saying, sir, for unsupervised learning, we need to we have to use for what we have to use unsupervised learning. Then
Okay, so unsupervised learning is better, isn't it? If you don't have to label it, right? So
hmm
unsupervised learning is used for grouping basically. The point is, if you really look at whatever data set you have, they are grouping, isn't it? One is telling diabetics, it is grouping at diabetic level. Another one is grouping at hypertension level. Another one is grouping at cataract level, isn't it?
yeah, yeah.
So, well, unsupervised learnings does that without label. It tries to find the similarity of data sets and how closer they are, and it groups it together and it divides them into groups. You have to tell the number of groups. If you say I need 10 groups, then it will divide the data. If you have 5,000, it will divide them into groups. We will try to use this and see that whether the grouping is done
Okay.
properly or not.
So
Yeah.
so you're saying, sir, for machine for unsupervised machine learning, and see for supervised machine learning, then already the classes are there. They're given, the labels are given. It's already classified. But then for unsupervised learning, then the labeling, and then the grouping and all, machine itself will do. So the machine itself will find it. We don't have to already give a label for it.
Yeah, so it finds it out using maths, which is like vector space, and probability. It does that.
Okay.
That does it. It is useful. Basically, it is used for labeling. Just consider that it's so difficult to label, isn't it? Probably if there's a one man sitting in, let's say, IE hospital, and then he gets it, he labels it. This is so much time it takes, right, to label it. But suppose you have a data set where the labels are not there, then what will you do? And you know that these data sets these data sets of let's say cats and dogs photos are there and it is not labeled, and you need to segregate the data. One is cat and one is dog. You know there are only two groups, so you will supply the algorithm. Please divide into two groups. Based on the similarity, it will divide cat separately and dog separately. How much it works? That is the question. It doesn't work that good, but going forward, if it could work properly, then it is like equivalent to general intelligence.
So for unsupervised learning, sir, then the it's so then the machine while it's learning and while it's the getting familiar with the data, it's also grouping the data. So we don't have to classify the data. Machine itself is classifying the data then.
Machine itself is classifying the data, and then once it classifies it, you need to go and provide the category for it, because machine just classified based on similarity. So let's say you had this eye sample, right, and you have what seven categories are there. You tell the machine, please divide into seven groups. It will divide into seven groups, and you will look at it, and the seven groups will be divided based on similarity.
Okay.
Consider all the cataract eye images would be similar, and consider, we cannot say, but then you understand that it is not perfect. See, unsupervised learning is not giving good accuracies as of now,
Okay.
because supervised is at least you are giving something, right? Unsupervised is like you find out yourself. Nobody is there to tell you. It's an unknown territory. Go find out which is what, right?
Okay. Fine. Fine.
It's like telling somebody, okay, yeah, unsupervised. That's unsupervised learning. Reinforcement learning is like, so suppose you play cricket, right? You said which what do
Oh
you
yeah. Yeah. Yeah.
you play cricket? Uh, Somebody told you how to play a good length ball. That is a learning, right? That is supervised learning.
Yeah. Yeah. That's supervised learning.
Nobody told you how to play it. You figure it out after playing, like you know what about playing 25 overs. You figure it out. Oh, the ball pitches here, and that is why I'm not able to look. I need to be cautious when the ball pitches here at that good length point, right?
Yeah.
That is reinforcement learning, and that is what human beings do basically. Anybody, no, we need supervised, like I'm training you, it's called supervised learning, right, for you. But then we also subconsciously automatically doing reinforcement learning. It is built into us. For example, a child walks, right, nobody teaches. I mean, do teachers, we do teach. If we don't teach, they will automatically learn how to,
Okay.
but it will take more time. We usually get walker for child basically. I don't know whether you know. There's a walker you get for a child. Then there's a walker is one three-legger, three-wheeled tool where it stands and then it tries to move it. Right. Even if you don't give, the child will learn at the end by falling. So that is called reinforcement learning. You fail and you say that you are not able to achieve the target, so you try it in different ways till the
So
time you
there's
get
like okay, like troubleshooting sort of like that,
troubleshooting.
or as in like so it's sort of like you're trying and then every time it's not that the condition is not met, then again you try like a different method.
Yeah, perfect.
Okay.
So, for example, if you are playing one place, there is a jigsaw thing is there. You have to find a way out, right? You will try a different path. The path doesn't work, so you will try another path,
Okay.
right?
So
You are
basically, yeah. So basically, sir, reinforcement learning, it's trying like different methods until a certain condition is reached, and then that method will be used then from then on.
yeah. So rewards. You need to go out. That is, you start in a tunnel and you have to go out some other place. So you have given the map out there, but then it is so much is there that you don't know what is the path. So you try to figure out a path. You come to a dead end. Now since you have come to dead end, now you will go trace back and then you will try another path, right?
Okay, so it's basically like a trial and error method.
Perfect. It is actually a trial and error method, but then there is the how do you mathematically put it in the programming is reinforcement learning. So there are different algorithms for it, and that is called reward based. So if you really look at it, you are supposed to go start in a tunnel and go out to a particular farm, right? There is a different paths are there. So you try one path, you get to dead end. So there is no rewards. So now you failed. So you have to come back and then try, right? So that's how it is.
Okay, fine.
Same thing happens in chess itself, right? If you really look at it, chess, probably you go on and learn from somebody, which will be faster. Otherwise, what you do is you start playing a chess and you know, okay, if I don't give space for the king, somebody else will come and kill, right?
Yeah, yeah.
So like that you understand this slowly. That what should I do? Different tactics. So that is reinforcement learning.
Okay.
So in supervised learning, the cat and dog input labeled photos are there, which is given to the machine, which is a model, right? So if you really look at it, what these dots are, right? So we are talking about deep learning here right now. So these are the neural networks. So their networks are connected, in fact. So I don't know what happened. It did not. It is supposed to get automated. Huh?
Okay.
Okay. Okay. So we'll finish this supervised learning and then we'll go to that part, that data. Okay.
Okay. Fine.
So output would be either cat or dog. So it goes through it, the learning happens, and then output is okay. So output is it's a cat or dog. Okay, Arif, let's see your photos then.
Okay. Fine. So yeah, sure, sir.
Okay, you have
So
any question you can ask here.
yeah, no, so sir, for what we are doing right now, so technically we'll be supervised learning, right? Because the data is already divided into groups, right? Using the labels.
Yeah. So
Okay.
what way has supervised learning?
hmm So for unsupervised learning, so technically it should be better because the machine, see the all we've just collected the data and then creating like the database, and for and for classifying the data, we don't have to do, the machine itself is doing it. So we just have to provide the data. The machine itself will classify. We just have to give the number of groups, and later once this is done, we have to identify the class.
Yes.
And then reinforcement learning is trial and error method then.
Yeah. So this is your unsupervised learnings. Look at this. What happened? So you know that is what you must be thinking. What are these? These are data points basically. A
Okay,
single data point. Data point means whatever data you get. A single image, it would be a single record. Yesterday, what we did a single record was nothing but what is the height and what is the age and what is the weight, right? So that is one record.
fine.
So in a record, when you say image, uh, so we don't see the label. The label is not, the result is not considered as the input. The we are actually trying to plot the input. So in case yesterday, whatever we did was we will plot height and the age, right, on the two dimensional x and y axis,
Okay,
and the color, whichever they group it, like we told, one, two, three, four grouping we said. The
yes,
points which
yes.
are remaining to each other are nearby. That is one group. That is another group. It's not very, and this is five. One, two, three, four, five. Five groups they are doing it, and
Fine.
they say that these set of points are similar to each other. So this is like you plot it. I don't know whether you're able to understand. We have to take one example, and I'll to make you understand that.
Yeah, yeah.
But
I'm able to understand.
so these are called as, they are nearer to each other, and hence they belong to one group, and like that. And reinforcement learning is you fail, and then you try to jump. You try to jump, you're not able to jump, you fall. Then you jump in a different way, you fall. Then you probably you jump in a another different way, and you pass, right? Like that way. So we
Okay.
will not. There's an animation here. I will show you with the animation afterwards.
Wait, okay, okay, fine. I can only see the slide right now. That's why I was just asking.
Yeah. So I have my G drive is actually loaded. I'll just check this link if you are able to download.
Okay. Uh, Fine. So, okay, it's a Google Drive then. Okay. Let me just need access. So I'll just request access then. Okay. So So able to see the request.
You're asking me the request to access it?
Yeah, it asked. It said that I need a request. I need to send a request. So I clicked the button.
Okay, I'll have to see the mail in that case. Wait, I have to see the mail. Yeah, I've given you the request, access.
Okay. Yeah, I got it, sir. So am I? Yeah. I'll download it now.
Yeah.
Google Drive can't scan this file for virus. It's too large for people to scan. Would you like to download? I'll click download anyway. Okay, I think I'll save it in document. Okay. Oh, it's a WinRAR. Fine.
Is it allowing you?
Yeah, no, it's I think it takes some time though, but it allowed me. It's saying that Google Drive can't scan the file for viruses. So I clicked it's okay, I clicked download anyway. So the WinRAR file will usually take a lot of time.
Yeah.
Okay. So it's not giving me any time. It's just saying down, just saying it's loading.
Hmm.
But I think it's okay. It's saying 100 MB done.
There is 1.3 GB. It'll keep
1.3.
downloading. It'll take some time to download.
Fine. Okay. Are you able to open it, sir, or?
I'm able to open. I'll show you to you.
So actually, I talked to the eye doctor. Actually, I know I talked to him, and then actually, and then also she's actually a friend of one. Yeah. So then, actually, the thing is, you were saying that many people have actually tried doing, even some Google and also have tried doing this, but then usually, see, for the project, this is fine. Like this scanning and then using AI and all. But many people have also tried, but it has not actually been that effective though. That's what he said. As a project, it's fine though. But if you want to like make it commercialized, then maybe not the best thing. That's it. You're saying something like that. Because some people have also tried doing this, like trying scanning from home and all that.
The point is, that's what I'm saying. The scan photos are different here. But see, Adi point was seen. I'll tell you what. Since you have taken a real case, you are able to relate how the AI works, right? If you didn't take the real case, if I would be teaching you some simple cases and all, you wouldn't have related it properly, right?
Yes.
Now we can actually start evaluating it, and then I'll just share the images with you, and then we
Okay.
will look into this.
Also, I don't know what other people have done, but I think project wise, at least for presenting, I think it should be fine. And also, and mainly it's just using the machine learning, right? And the database is already there also. So I think hopefully it should be okay. I think so.
Yeah. See, he will tell he's a doctor, right? At the end, for him, it's a threat. See, this AI is a big threat to doctors. Try to understand this. A lot of doctors, lawyers, they'll be replaced over a period of time. They will
Okay.
not be required in future. Doctors are no
Okay.
more required after this because doctors study this only essentially, isn't it? And
Yeah.
and they were charging something like this. Now with these tools, once you provide these tools, The person just have to go and get the machine. Somebody has a machine. He just goes and gets the eye photo, and then feeds the eye photo to this thing, and this will tell that whether this is a what type of problem is this diagnostic. So doctor used to charge something like, what, 1,500 or something like that. That is
In fact,
not.
yeah. In fact, actually, I was also saying that I think my dad had also initially said that you can go and ask, but I was also like, see, if this is actually, if this is, technology is developed in the future, then you're right. Actually, it will make they make the people obsolete. At least most of the people in the hospitals and all that.
It is going to happen.
Hmm.
In fact, there is no other go. There are doctors. People will pay heavy money to the specialist to develop one-time software. The specialist will come thinking that I'll get a lot of money, and then once that software is developed, the specialist is gone.
Hmm. Yeah.
So this doctor will say that. There's no doubt about it. In fact.
Hmm.
Okay, so now what we will do, we will inspect the data and see this is how the data looks like. And usually this is how the data is. So there is one folder here, ODIRSK is there. Inside there is something called testing images, training images, and there is an Excel sheet describe the data.
Okay.
So now look at the training images. Look at this. There is something called zero right and zero left and zero right. So let's look at zero left. So zero left is this, and the zero right is this. Okay. Now let's open the
Okay.
Excel sheet. Let's open the Excel sheet. Excel sheet says that, look at this. This is your tabular column, right?
Yes.
Patient age, patient sex, left fundus. Okay, it must be left eye, right fundus, right eye. What do I don't know what is fundus.
Yeah, no, I think it means I only.
Yeah.
Uh, but I
Well,
think, yeah, okay, it's
it's this
also,
fundus is this looks like this is called fundus in eye probably not. Look at this image, right? Circular image.
it's the part, I think, a part of the eyeball is opposite people.
Yeah. So this zero dot right? So that is what is zero left dot JPEG. So we had this. Look at this data set: zero left dot JPEG and zero right dot JPEG. Okay. For one person,
Okay.
there are two photos: zero left and zero right. Left diagnostic keyword is cataract. It's a cataract. So the point is we have to. So this is called data analysis. Okay, which very important phase of not computer. What do you say? Artificial intelligence. Data analysis. What you do is you open the data and you start inspecting the data.
Okay,
And
fine.
there are a lot of phases of it. Right now we are just inspecting it. There are phases of different way to plot it, different way to visualize it, to give more insight about it. So that we will be studying. Zero left, and so this is a cataract. So what it says is left eye is a cataract. Okay, and the
Okay.
right eye. What is the problem with right? Normal fundus. Right diagnostic keyword is normal fundus. Okay, this is normal, and this is cataract. Oh my God! So cataract. Can you see? There's no blood. Shit. Can you see the similarity?
Yes,
Cataract.
yes, I can see.
Here
The
at
only
least blood.
thing, the only
Yeah.
thing is, I think it's a very like a super close up, of the eye.
Exactly,
So,
and that is what I
so
was thinking. How do we do it? We cannot get the patient data like just like that, right?
yes. So I don't know. Maybe once the picture's taken, is there any way you can just zoom in on the picture or something? I'm not sure like how, but
No, we can't have. See, this is a fundus, right? So this is the data of the fundus. So
mhm.
if you really see this, and that is what the is the thing. Here's the data set, right? Right eye fundus photography. So eye fundus. How do you get eye fundus? There's a special machine would be there.
Mhm. Okay.
So this you cannot get by camera for sure.
You have to use a certain technology you have to use, right, in order to get the from this photograph.
Rear of an eye. Fundus photography involves photographing the rear of an eye, also known as fundus. Rear. Specialized fundus camera consisting of an intricate microscope attached to a flash-enabled camera are used in fundus photography. The main structure that can be visualized on the fundus photo are the center and the peripheral retina, optic disc, and macula. Fundus photography can be performed with color filters. Okay. This is the one. The fundus camera is this.
Okay.
Okay. So the point is, so diagnostic. So whatever we are trying to develop, the recipients are the diagnostic clinic. They are the one which can use these photographs to analyze what is the problem without giving it to the doctors. So going forward, if we could see that, we can imagine going forward what will start happening is people having centers of diagnostic where they do not keep an eye doctor to tell whether this is a cataract or not. Rather, they feed the image to the machine, and machine says whether it is a cataract or not. So you save on the cost of giving that fees to the doctor. And this
Okay.
photography could be taken by any person, right? Any trained person. Not a big deal. What is a big training? 2 or 3 days of training should be good enough for a person to do this.
Yes.
But to find whether it is a cataract or not, it takes 5 plus 2 years of training. 5 for MBBS and another 2 years for eye specialist. And God knows how many years of training the doctor does over a period of time to become that specialist who can tell whether it's a cataract or not. The same thing can be trained in the machine in, let's say, 5 days, and the machine is able to tell. Right? So you can understand how cheaper it is. Once you have a data set, the machine once trained, over the cost is negligible, and the type of benefit it can give is huge. And so you don't have to charge first of all, there is a shortage of eye specialists, so they charge that much money. Once the software is there, anybody in the world can use it, and the amount of money which you can charge is probably 1 rupee per diagnostic. And how many people are there in this world? Billions of people. Probably out of that, if a million of people test their eyes, and let's say, let's talk about 100 rupees, okay, not 10 rupees. 1 million into 10 is around 10 million. That's the amount of money you can generate. I'm just telling 10 rupees. Consider 10 rupees versus 1,500. I don't think so. This will be a higher price for finding eye thing. Whether this is not, that they will be charging even higher money, right?
Oh yes. So I think there's one more one. One I think, can I just share the screen? So there's one more data set that was there initially, but this one I did not look at it that much because the total images there were only 100. But actually, the thing is that they probably given a review, maybe that would have been better. I'm not able to see what type, but in this one, it's giving, I think, images of the eye proper with the disorder like bulky eye, cataract, crossed eyes. The
Where
total,
which one? Can
total
you
view
share?
disorders are there. Yeah, I'll share my screen. So one sec.
Okay.
I think once you stop sharing, I think I can present then.
Okay.
Okay. Yeah. Okay. So I think you're able to see it. So are you able to see my screen?
Yeah, I am able to see.
Okay. Yeah. So over here it's talking about the context and the content, and it's saying over here the total three disorders are there. Though even though it's being 100 images, yeah, I think it's saying that over here it should be easier. I think it's saying it should be easier to train over here, and I think they're giving, I don't know, maybe you can try this one also. I think it's giving the proper eye image for three disorders. I think I mentioned the bulky eye, cataract, and crossed eyes. Only thing is, I'm not sure how the image will look like. See, this is a fun test, but over here, I think it's giving for the eye. This
Okay,
eye.
give me. Yeah, give me. Let me see. Eye disorder data set, right? Okay.
Yes, I'll send this in the chat also. The only thing is, this is only 100 images. That's why I was not too keen on it. But this one is saying that this data set is I think it's saying that it's slightly easier to train and less pre-processing compared to the other data sets.
Okay.
At least that's what it's claiming over here. Oh, okay, so I think it's done downloading the WinRAR.
Actually, whatever problem we are trying to solve is a difficult problem because so many categories are there, right? So
Yeah.
there are some people who have worked on, they have only worked on something like diabetic retinopathy detection.
Hmm.
So there it is like it has been solved to a very high extent because only one problem you are trying to solve there. Whether
Yeah.
it is a
Over here
yeah.
it's three disorders max. So I think hopefully maybe we can narrow it down also.
Hmm. It becomes a difficult problem.
Yeah. Yeah. Okay. Yeah. It's done downloading now for me. Okay. Image format is grayscale though. So actually, the thing is, it's not RGB. It's a grayscale. So I think the image
No, how do you say it is RGB? It's RGB. It's color also is there in this.
really no. So it's saying that it's saying that the image format is see to
Oh,
yeah image
no,
format
no.
is saying is grayscale. That's what it's saying in this one. The eye disorder, not the fundus one. The other one I sent the eye disorder data set. This one is
Okay.
saying is a grayscale.
This is an 18 MB of data is there in this.
Hmm. See the actually the ocular disease recognition is a good database, but the problem is it has only fundus photographs. That's the problem.
See, that is why skin could be one of the place which could be used. Skin cancer, right? For skin disease could be there. So many skin disease, right? So that is one which you could do now. So if you want something which could be useful for the people, I think the one which could be useful is that skin data set. We can look at it. See, the point is to learn. You can use any of this. So what fundus, right? So fundus photo could be there in the clinic. It's not that it's not possible to get in clinic, right? So, but then there is a lot of work involved for doing to go there, right? But then as a part of just testing it, right? Once you create it, as you said, the 20% of data we will not provide for training. We will train using 80% of data, and then we will see with the testing data whether it is working properly or not, and what is the accuracy, right? Once we establish a good accuracy with this thing, given other fundus data, it would work the same way, right? So it's not that we cannot work on it. We can work on it. And once we do this, we go to the clinic and say that eye clinic, okay, you give us some samples which you have it, and I my software will tell you whether what problems are there, and you can see that the doctor would have labeled in any case, and then we will also do it, and then the only thing is that it's a threat to their business, right? Threat to
Yeah.
doctor's business, but it's not a threat to diagnostic business.
Hmm.
But diagnostic business is would change over a period of time. This is how it is going to work. But then you are doing a school project, so let's not go into that level,
Yeah, yeah, I
right?
understand.
Let's look out for some skin images, right? Skin or dental images.
I think only one good data set is really needed.
Yeah. See what happens nowadays, right? So they want to see which crop is having what disease. Even that is very good. So get a disease plant and see what is the problem with the disease. That's for farmers.
Yeah.
I think in fact there is one full chapter on how do you collect data and how do you analyze it. That I will go through for you in the next
Okay, fine,
class.
sir.
Because what happens is that's a major source. Otherwise, what happens, no? And there is a procedure of scooping the problem also.
Okay,
If
okay.
you follow that, then there will be a bigger impact. Otherwise, what happens is we are just moving just without any systematic way. So once you know what is artificial intelligence all about, then we'll go to there's something called problem scoping first. And problem scoping, you ask certain questions.
Okay.
Just 1 second. Hello. Yeah, Adif, so what happens in that case? You have the whole scope is created. In that scope, you need to have ask the questions. Basically, and let me just open my slide and I'll tell you.
Okay. No, no, so are you talking about this data set or the other one? Because two I think are there. Now, one is this one with the fundus one, which a lot of images are there, and also they have color and they have pixels. Now, only thing is it's only it's a fundus photograph. It's not a image of the eye. The other one, I'm not sure if image of the eye. I didn't check it yet, but it has only 100 images. But I think it's grayscale also. I don't know. So, but
Yeah,
I
it is
think that's
grayscale.
the eye
It is grayscale. It is grayscale. Yeah.
is grayscale only. So I don't. But so is it image of the eye or is it only fundus?
So I just saw that. So it is given and the pixel values are given. So what happens is it has, if you really look at it, it has how many pixels? 50,132 pixels are there. So what is there? It is a size. It's an image format is 332 into 151.
Okay,
Right. So we need to extract that image, and once we extract that image, we need to look into that photo of that. So that requires programming because I'll show you how exactly it looks like.
fine. No, the only thing is so grayscale. Will that be a thing or a problem or anything? Because
So no, grayscale cannot be a problem because you can actually take a photo and then convert into grayscale.
fine. Okay,
Take a photo and convert into grayscale.
okay, fine, sir. So I think maybe we'll stick with this data set for now. But is it showing the image of the full eye? I think I'll try downloading it also. One sec. Just saying there's a problem. I'll try downloading it again. And also three disorders are given. So
Yeah.
so can you say can you again can you censor because I also and so that I'm able to
Okay, you're not able to. Okay, let me see. I can say share in chat or not. I'll show you the data. Just and I'll show you. I'll just show you the data right now. So this is the data looks like. Look at this. Can you see it?
yeah I can see so okay yeah, it's a
Type and this. These are the pixel values. So
yeah
0 to 255 is there, right? So I have to extract all these columns. There are 50,000 columns are there. For every section, I have to extract it and convert into image. We
okay
can code it and then right away, if you want to do it, we can do it. Right away, we can do it. It's not that, not a big deal.
fine
So and then we can see the image from there. So but then requires a coding impact. So I will extract and keep it. Okay. Tomorrow when we have Tuesday class, we can see this photo. just for telling you. But apart from that, if you really look at the data, try to look at the data. Data has a lot of things, right? So don't think that
Yes.
once we have a data, we'll give to machine. No, it's not so straightforward. It is not at all. Look at it. You have to understand how the data is there. So you need to left eye photo you have to take out, right? And then you have to take the label also. Now this becomes a set of your input to your this image, and this thing, even this is your image. This is also input, female, and the age, because it depends on cataract. For it is depends on this also, right? This photo plus these are also the variables. Yesterday we saw the variables, right? Yeah, height, and we saw height and age, where the variables, and the output variable was weight. Here input variables are age, gender, photo, and this is the output. And what is this? These values? We'll have to see what are these values. So it will define there. Let's go and see. So this must be a category. You see, this is a category. There's one category. They made it that one category, one variable of category was converted into. It has values 1, 2, 3, 4, 5, 6, 7, 8 values were there. Yesterday we had 4 values, right? At ethnicity, that category, they expanded it so that it could be converted into a category variable has to be converted into a normal variable using this. Other values will be 0. One value would be there.
Fine.
Yesterday, you remember yesterday I told you those
Yes,
will.
yes, yes.
If it is an Indian, then it cannot be American, it cannot be African, or it cannot be Chinese, right? So this is one variable. It was one variable that they converted into category. So let's see what was that. It's a good way to see how exactly data is. So this is the one, right? So what does this say about data? So it says, so this is your categorization. 1, 2, 3, 4, 5, 6, 7, 8.
8, totally 8 categories are there.
Total 8 categories are there, and here also 1, 2, 3, 4, 5, 6, 7, 8. So it says that it's a cataract. So cataract. So it's a result. This is the output result. So that's the whole thing. We have not done the fundamentals of it, so it will be difficult for you to understand. People take all professionals also to come to this level, that how exactly it is categorized takes a lot of time. Why it is done like this? There is a science behind it. There is a mathematics behind it. I will tell you the Eagle's point of view. This is called as, basically it's called as sort of a softmax function is there. So we'll have to see what is the softmax function, and this is called as your one hot encoding. One hot encoding. So how do you put this? This variable has this categories, right? Yesterday we told that ethnicity. How do I put it as a variable? It was very difficult because one was Asian, one was Chinese, one was Indian, and one was American, right? So what I told them, I'll create 4 variables. I'll create 4 variables: American, Indian, Chinese, and African. And the one value would be associated with whatever it is, right? So in this case, if you say that if it is a cataract, then value of 1 would be given to cataract, all of them will be 0. Similarly, there are possibility that there can be 2 things. There is a D means diabetes, as well as there is a O means other disease by abnormalities. So then both of them will become 1.
Okay.
See here 1. Why? Because here you see for this guy there are two values are there. One is D. So D is for this is telling macular epiretinal membrane and mild non-proliferative retinopathy. So both of them are there, and that's why they probably this mild non-proliferative retinopathy belongs to other disease because it is not mentioned here. So that is why we put that at others. And this one is one for this is moderate non-proliferate retinopathy. So here so it is telling this as 1, right? And the other one is that. So that's the diagnostic from the doctor side, that he has a diabetes as well as he has a diabetes as well as he has a other disease as well.
Okay.
So okay, fine. As many, so now this is the input data. Now the whole thing is, now you have to understand how do you provide this data to the machine for training. There it was so simple. Your whatever you did, that was Adib was given as a photo. The other one was your background, and the other one was your mobile, right? That is all the input was, isn't
Okay,
it?
fine.
And then it was supposed to decide what is the output, based on which it told you whether it is Adiv, this or that. So there the output variable would have been Adiv, background, and one more variable would be mobile, right? And
Yeah,
whatever output came, it was telling 100%, right? 100% to Adiv it gave, or else it gave
yeah,
100% to, depending on 100% to background or 100% to the mobile, right? So again, there were three variables as output, because it has to categorize, right? So that is how you train a machine, telling that given this input, my output is this. How will the machine knows that? How will machine know that it is it is what do you say, Adiv, background, or mobile, right? How will it know? It has to, you have there, you had three variables to the machine. When you trained it, no, the label was provided, the actual input which was provided as input was this. What I mean, whatever you have three images, whatever image your, how many images were there? One was around 200 images of Adi were there, right?
yeah, yeah.
200 images. Against the 200 images, for every image there were three columns which were also given as the input to the machine, and that against the Adif column it was given as one, and all rest background, and for the phone it was zero. So machine understood that okay, this is Adif.
Fine. Okay.
Because Adev as a string you cannot give inside, because remember in machine learning and AI only numbers can be fed as the input. You cannot give non-numbers there, because machine can never understand. Because we yesterday we talking about that y is equal to f of x, right? Y is a function of f of x, and
Yeah.
in case of whatever you wanted to prove, whether it is Adev or it is a mobile or is a background there, right? What was the y? Y was either Adev, background, or mobile, but then it was a function of the image function. It was f of x, and x, how many features were there? Whatever image dimensions you had, that was the input, right? Images were the input, isn't it?
Yeah, yeah.
And but then also you said that what was the output as well, so that machine can do. I think we have actually gone too much into before it. If we go systematically, you will appreciate it. Otherwise, it will become complex for you. Uh, okay.
Sure, sure.
Right now,
Yeah, no,
it
no,
is.
I understand sir, that you're trying to classify based on that, and you're trying the different parameters are there, so you're trying to match based on that, and then after they will give also, right? So when you're doing this machine learning, and then when we're trying to find the image match and all, when we're comparing the database again, when we're doing this with eyes also, are we going to give a match also like just like 90% or 80% like match based on that?
Yes, it will. That will be the output, because that's why I told you probability is always percentage. I think, see, the rule based programming was, if this happens, if this happens, this happens, this happens, this happens, then it means that it is this. But in machine learning, deep learning, it is like you are giving a data set, and from the data set how well it has learned, it will tell. So even if you go and ask a doctor, it will say, I think it is a cataract, for example, right? And they are wrong sometimes, right? Any doctor, if you say in this world, whenever they say that something is there, they say it with percentage. They're not sure. Doctors go wrong so many times, right? Even in the case of coronavirus, also when they are testing, do you think that is always 100%? They go wrong also, right?
Yes, yes.
So everything in this world, whatever we do measurement, it is always with some probability. The probability would be 90% of the time it will be right, or 10% of the time it will be wrong. Either it will be 99% right and 1% time it will be wrong. That's how it is.
Okay.
And that is what the accuracy is all about. That's where you measure the accuracies. And you say that this machine can predict the output at how many percent of the time it is able to predict the output rightly. In fact, the real world works like that only, right? And that is what we are trying to mimic in this artificial intelligence also. That I think the result is this, and my probability of thinking that this result is this is 95%, or let's say 90%, and the rest 5% I give it to, probably in your case, whatever you had, Adiv, mobile, and the background. I think 95% it is Adiv, 2.2% it is background, and 3% it is mobile.
Yeah, yeah.
100%. So that's how the output would come. But it was so well trained that it was able to tell 100% Adim, or it was able to tell 100% to mobile, right? But sometimes if you were fluctuating, it was 50-50% it was telling, right?
Yes.
Yes. So, for example, to train this, it is possible to train, and we need to take this as one of the input data. These are also input data. No, not ID is not there. Patient age. We have to convert this into one hot encoding. Gender, right? Female and male. We'll have to create two columns. If it is female, then one would be there, and male would be zero, and that would be the input. Okay. This has to convert, because how will you give input? Because female you cannot give as input to machine, right? So this gender would convert into two columns. One would be female and other would be male. And if it is a female, then the two columns value would be like this. Under female column it will be 0, and under male column it will be no, under female column it will be 1, and under male column it will be 0.
Okay.
And this would be another input. So this image is of what dimension? Let's see. So this image is it is not given. Okay. Oh. Okay. Okay. It has not given the dimension of the image here. Okay. So whatever is the dimension of the image, for example, this image, whatever is the dimension, that would be, let's say, for example, this image dimension was 500 into 500. So then 500 into 500, if you multiply 500 to 500, you will get
25. Sorry. Yeah. 250,000.
250,000 would be columns, because as you see here, columns are there, right? So if you really see this image, these are the columns of the image, right? These are the image, flattened image.
Yes.
So this
So
this
could you go to
pixel,
the other? Could you go to the other database also? I want to check the image also for that one, for the grayscale one, because this is for the fundest one, right? So it will not be practical to use, but maybe for the fun, for the other database, the
you want to see that?
yeah.
Then I have to write a code. How can you cannot see just like that, right? You'll have to write a code over that.
No, over here. So what have you done over here?
Where
Like here to check the fundest photographs. So how you
that is there, that is there inside this only. Photo is given.
okay.
Did you extract it? I sent you the data. Did you got it? You go extract it and just see this. They have extracted it. It's already there. It is there in the directory.
So they didn't okay. So for the grayscale one, they've not extracted it yet. Then
Yeah, it's inside the Excel sheet.
we only
Yeah,
have to extract it. Then fine.
yeah. But then it is so good that it could be directly used for machine learning.
Okay.
See, but these are the features I told you. No, a image of size 10 into 10 would have 100 features, right?
Yes.
Similarly, this is the image of size. This is the image of size 332 into 151.
Okay. So 500. So 50,132 features then.
Yeah, so 50,132 features are there here. Similarly, that is what I was trying to tell you, that the input of the machine learning, for if you are giving this photo, whatever, if this photo was, let's say 500 to 500, in that case, that many features, 250,000 features, exactly like this would come. Like you have it, right? You will expand it like this. The numbers would be there. So image is nothing but numbers. Every pixel, right?
Yes. Yeah.
So you expand that, and then this is one column, second column, no second column, two more columns will come, right? Because gender has converts into two columns, female and male, right? 1 plus 2, 3 columns, 3 columns per 250,000, which is 250,000 plus 3. So 250,000, 250, 50,000, 3 columns would be there. This I will use it at different data set, and this I will give it as an input.
Okay.
That, and this is what, this is diagnostic is cataract, right? And then cataract is given as categories converted into 8 columns, right?
Yeah.
That is 8 columns. So now this becomes my, this is my output, remember. So output is not given as a training. So I think let's do one thing. Let's take a simple toy problem and understand. Otherwise, this will become problem. What happens is output is not given as a input. Output is output, right? Input is just the image. Because what happened yesterday when we were doing it, what was the input? Input was height and the age. Weight was the output. So to the machine learning, I'll give the input as the height and the age. and the output what I'm expecting is I will correct it. So that's the science behind it, how it is done, and that is what we have to do it. But right now, remember that one is input and one is output. So remember, this is output. This classification is the output, but then this is the input. Forget about this. This is a part of classification only.
So
So
the one will be yes, and then the zero will be no. Then right. And so then
yeah,
for each one only one. Yeah. Okay. It's
yeah.
identified. I
So
understand. Okay.
yeah, so this whole thing would be the input. Probably I mean, both the images you can concatenate it. So this becomes a two
So
fifty
based
thousand.
so
Yeah,
based on these different conditions, you have to identify, right? The output, final output, only one output will be given then finally based on the different categories.
yeah, but then you have certain places. Some people have more than one problem. You see this?
Maybe. Oh yeah, yeah. I can see. I can see. Okay, so output will be given based on the different conditions, right? It will identify and it'll cross-reference based on the. See, for each image, it will cross-reference and then it will identify and it will display.
Yeah, so this is not a this is not a single classification problem. This is multi-class classification because here multi-class is their classification. One and two is also possible, or three are also possible. You see, this is called as multi-class classification. One is called normal classification, where you did was a normal classification, whether it's Adib, phone, or the background, right? That was normal classification. But here it is multi-class classification. Why? Because two classes are there. One, it is diabetes, or it could be H, whatever H means, right? Yeah, H we can see here itself. Here. So it could be two diseases, hypertensive retinal problem, right? So hypertension is also there, and what is this? Diabetics is also there. So two things are there. So this is called multi-class. This is a tougher problem to solve. And your doctor, whatever he said was actually right.
Yes.
Classifying just that it is diabetes is easy problem, but classifying both together is a difficult problem.
Yes.
Yeah. But then that's what needs to be solved actually, right?
Yeah, yeah. So, so that's the problem then over here.
But it's an interesting problem, Adev, I'll tell you. And what we need to do is the input would also have this image and both the images. Both the images would be given as input to the machine. Both the images. And how do you give it? This is 250 pixel, 250,000 pixel, right? And this is also 250,000 pixel, both the images.
Yeah, yeah. That's true. That's true.
You will concatenate it, it will become 500,000 pixels.
Okay.
So and then you concatenate this. So the one row which is there right now here you have 50,000, right? So I mean, like you can understand there will be 250,000 columns like this, and another 250,000 extending beyond that. So that becomes the input to your machine. And remember, why vector is so important, because a vector could be two-dimensional, vector could be three-dimensional. Here in this case, if we after concatenating these two images, my vector size would be 500,000 plus this female is 2 and one more is there, age, right? So it will be 500,000 3 would be the dimension of my vector.
Okay.
It's a vector. This is vector. Do you understand what is vector? I don't know if you don't know what is vector, but that's a vector, right? So and that's where whole vector calculus comes into picture here for finding what values are similar and what values are not similar. Because at the end, if you really look at it, the whole science behind this is like all the cataract will have a sort of a similar image, right?
Okay.
Isn't it? So images of all cataract will be similar. So whatever vectors you create out of a cataract image would be closer to each other. They'll be similar in number. The one with diabetes images would be different. So let's try to see some images with diabetes.
Okay.
Okay, so now this is one left, right? So let's go and see one left. One left is a normal fundus. So this is not a problem. So absolutely okay. And can you see? Look at this normal fundus, right? One left. And let's say zero right was also normal. Look at it. There is a similarity. Look at it.
Mm-hmm.
See the right. Look at the right one. And look at the one right
There
is
is
normal.
similarity.
And one left is also normal. Sort of similar. Can you see this pattern
Yeah,
coming?
I can see the patterns. I can see the pattern.
So what we do is we actually, what is vector? See, if you really look at this image, is a lot of pixel values are there, right? And then if you convert it to a vector, which is nothing but how do you convert this is a vectorized image?
Wait,
One.
so one second, can I just take this? Somebody keeps calling, so can I
Okay.
just take this? Okay, thanks, sir.
Yeah.
Okay, sir. Never mind, sir. That person disconnected.
Okay. Okay. So what we're trying to do is we are converting the image into a image is anyway a vector only. So we convert into a vector, right? Like this. And I have not taught you how the images are interpreted. So we will do one exercise next class where, as I told you, right, we will create a how computer sees the image. Actually, you have come to know already, but we will see that one toy example so that you get it more better in your mind. You already know it right now how images are, right?
Yes, yes.
It has value from 0 to 255. Basically, black, no, not red, green and blue pixels are also part of it. But then this is how it is represented here, and this was the normal fundus. Let's say one more which is wrong, 2. So here something is there, it has a diabetes, right? So let's look at the diabetes one, and then there is a diabetes here also with the fourth left also has a diabetes.
Yeah.
No, it doesn't say which eye, right? Look at this. There's a problem with this data set, right? It never says which eyes. Whether it is the right eye, the problem is there, or left eyes.
Yeah. Oh, yeah.
And
That's true. That's true. I can see that.
how do I know? Because see, this diagnostic is fine. It says left diagnostic keyword is given here, and the right diagnostic keyword is given. But in the output, it says diabetes and O means other disease. But for which eyes? I don't see that in this output. So that we'll have to modify in that case. We'll have to see. You got my point? Which
Yeah,
eyes?
I got it.
I need to know for both the eyes. Otherwise, how?
Mm-hmm.
So
So,
well,
so that's what looking at both the eyes, right? We're comparing, and based on that, it's giving the output.
yeah, it's giving the output. So now, Adib, so given a data set, it is such an important thing that whether the reliable data set is there or not.
Yes.
Somebody has given this data set, how can we say that this is right, and whether the data set is given proper or not? I am seeing clearly that I am not able to distinguish from the output that whatever he has given NDC, GC, it is not clearly telling whether which eye is having the problem. It just says that for both the eyes together it is giving me clubbing it. But at the end, patient wants to know which right eye is a problem or whether left eye is the problem. So there is a problem in this data set right now. So it is very important that getting the data set right and from which sources you are getting the data set is also very important. There is a whole chapter out there that when you scope a problem in AI, how do you scope it? And you need to actually, there is a systematic way of checking from where you get the data and whether data is reliable or not. So those things are there, and which are the sources of reliable data sets. And if it is not there, then from where do you get it? How do you make it sure that you get the reliable data? Probably you'll have to go to the clinic and get it. The various sources of it. This is one data set.
Yeah, yeah. Okay.
Okay, fine. So now let's look at this guy diabetes, right? So this is number 4. Okay. So let's go to number 4. What was 2? 2 was normal, huh? Is it? Let's say 2. What is 2? 2 has a diabetes here. Okay, and diabetes as well as what does it has? You are also opened it and it has other disease as well. So to look at this, there's some problem. So this is
But
yes,
the overlapping problems are there also. Even though the color scheme might be different, the overlapping problem you can make out also.
yeah. Look at this. This one, no, some problem is there. See, so let's see other diabetes samples, and what is the fourth one? So let's see. This should match. Second and fourth should match. So look at this fourth one. So fourth.
Okay.
So here you can see there's a dots here, right? And then there was a second one also. There are dots here, which is sort of matching there. Dots there, right? But then fourth one, I think there's only one problem, 2 problems. Again, he has the same set of problem. Look at this and this. But then you say they're not exactly the same. This is
Yeah, yeah.
Sort of both of them says the same thing. I think this is a difficult problem set. I think you should
Yeah,
not
no, I
take up.
don't think we should not take this up, right?
You should
From
not
the
take
other
up.
one, maybe, but and the other one, I because see over here the main problem is one, it's not specifying which IA when it's
Hmm.
showing the output, and also too many conditions also, right, based on the image.
Too many classifications are there. So this is like multi-class classification also. I think for your level you should be doing one or two class classification only, not much more than that. So there are problems at which I have, which are only finding out only one problem at a time. So that I will
I think
search
this
and
one, yeah, yeah. I
yeah,
think this data set I sent it's only 100 images, but it has only three classifications,
yeah.
and and yeah, and also only thing is extracting the image. That's all. Now we have to use a program to get the image.
Yeah, so we'll have to extract the program. Yeah, so that we'll start doing that using Python. We have to do it. There's a library called NumPy and OpenCV. We use those two libraries to do that. And there is one more library for Panda which will read the step table. So we might not use. We might have to use Pandas for reading this, and then so these three libraries we use to do that.
And so the AI will be need to be used then for the to learn and then give output based on that.
Pardon?
So then the AI will be used later then, right? After so for extracting the images we have to use so to extract the image and feed the image data to the AI we need to use the program then.
Yeah, we have to use the program, and the AI is also nothing but a program itself. And you have those AI programs written in various languages like Python, C++, and all. And Python has the most richest set of libraries for that. So you have a scikit-learn for machine learning, and then you have uh, PyTorch and TensorFlow for deep learning.
Okay.
And OpenCV gives you out of the box models for doing all this in a shortcut, and that's where we will use OpenCV for doing all our thing because it has already built in models on deep learning and machine learning which we can use it, and it is already trained certain models. We will use that already trained models for training it.
Okay.
So essentially we'll be doing OpenCV here,
Okay.
which is a Python library.
Hmm.
I think since you are enjoying it, we should be in fact doing it in a systematic way so that you get the crux of the AI also. And you ended up, and then we start doing open. Since you have already gone quite ahead, in fact, within these three classes, you come to know how the data looks like, how the data is read, how the output looks like,
Hmm.
and then you had an overview of what AI is like. I'm still giving you those things. We can start using like whatever data set your 100 photos are there, right? So from that 100 photos, we'll extract the black and white image, and we will try to use that for training, and we'll classify that, as a toy data set. And
Okay.
let's see if it works out well. That's good, right?
As like a practice then, right? Before doing this data set then.
Yeah. Before
Sure,
taking
sure.
anything else, yeah.
Sure, sir. Okay. Yeah.
So this is out of picture. This is a very complex problem. This is out of
Yeah,
picture
yeah.
as well.
Okay. 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 Fine. So I won't bother with this then.
Yeah, and we will try to see once you see that one basic one, probably that could be a project. Or else, if you don't want to take it and you want to take it higher, we will see if it's skin disease or something else. Or there are so many other things, right? Even plant disease are there. So many things could be there, but then that itself could become your project at the end.
Okay. Yeah, yeah, because a lot of months I think I have to present it by at least by next year only has to be ready by at least by Jan Feb or this December. So time is I can create and I can keep updating it also with the idea
Yes.
itself. Mhm.
Yeah. Yeah. Right. So, what else syllabus you have? Do you have AI syllabus this year in your class?
So AI syllabus I don't I don't know. No.
Okay. Python.
Python will be there, yeah. So actually, Python will be going into more detail. It'll be about. Wait, I think I have the syllabus over here. Yeah. So actually the thing is, so in 10th grade, so we have a reassessment also an exam, electronic exam. So they want to finish all the syllabus by October because they want us to focus on this personal project and also the yeah 10th E assessment. So
10th.
I don't think the electronic assessment we have so for
Okay.
at the end. So yeah, they'll want to. So then they want us to finish all the syllabus by October.
Okay.
Yeah. Yeah. So for design, so for Python, so all the stuff we've done already, like functions, after dictionaries. Then for syllabus pending, for I think for Python, it'll mostly be the Pygame installation and development of games, classes, objects, and exception handling and object-oriented approach, the tuples and strings and list methods and all. But yeah, mostly be focused on game and app development. So actually, yeah, maybe we can I can use that app development. Maybe like once this AI program will be successful, maybe I can try and make an app also out of that.
Yeah, yeah, we will do that, right? Yes.
Yeah, yeah.
And Pygame, can you send me the syllabus? Take a scan of it and send me in the mail so that.
Yeah, yeah, sure, sir. Okay, I'll do that. I'll send it by mail.
Okay, so Tuesday, what we will do, this 100 data set, what we have now, we will extract and we will see the image out of it.
Yeah, yeah. Okay, fine, sir.
Okay, fine then.
Okay, bye, sir.
Bye bye.
Bye.
Bye.